Today's class contains important problems, question 14 and question 12, principal argument on the axis, amplitude question on the imaginary axis. Let us start the question number 14. If 1 plus iota by 1 minus iota to the power m equal to 1, then find the least positive integral value of m. Okay. Solution 1 plus iota by 1 minus iota all to the power m is equal to 1 implies 1 plus iota by 1 minus iota. To multiply this with its conjugate 1 plus iota, and as a result there also 1 plus iota to the power m is equal to 1. On simplification 1 square plus 2 iota plus iota square by 1 square minus iota square all to the power m is equal to 1 implies 2 iota, and here equal to 2 to the power m is equal to 1. 2 to cancel, iota to the power m is equal to 1 implies m can be 4, 12, 16 and so on. All multiples of 4, and minus can also be there. M is equal to minus 4, 12, 16, but by question positive least integral values only. Okay. So here obviously m is equal to 4. Next question, find the number of non-zero integral solutions of the modulus of 1 minus iota all to the power x equal to 2 to the power x. Okay. Understand the insight of the problem by taking a simple example. Suppose x is equal to 5, 9, 0 and 4. All are the solutions of this. Suppose for the time being. Then the question says that all the solution that value should be non-zero. So non-zero are this and these are allowed, and such solution numbers. So obviously number of solutions will be 3. Okay, 1, 2, 3. So let us start the problem solution. Modulus 1 minus iota to the power x equal to 2 to the power x. Now this modulus means 1 square plus 1 square to the power x equal to 2 to the power x implies root 2 to the power x equal to 2 to the power x implies 2 to the power xy 2 equal to 2 to the power x. Now bases are equal on right and left 2. That's why x by 2 equal to x. This implies x is equal to 2x. But x is equal to 2x cannot be possible. It is only possible at x is equal to 0. Implies x is equal to 0. Now by previous explanation, okay, we see that x value has come 0, which is not a non-zero integer. Okay, so that type of number is 0 here. So ultimately the number of non-zero integral solutions also 0. Okay, hence the number of non-zero integral solutions is 0. Okay, now we are moving to the concept of principal argument on the axis. Look at this orgone plane and first consider this point for which we want to find the principal argument. That is, this is the angle, okay, negative angle. For that we need to find out first magnitude of this. Tan inverse minus y by minus x, okay, is equal to tan inverse plus y by x. Okay, so some value we get which we do not know before calculating like that. Okay, and after that minus of pi minus this we get. Okay, now we are coming to points when they lie on the axis. Consider this one first. You see that if this is this line is rotating and it is going there, then this imaginary part is 0. So only this one, and it can be written as x plus 0 iota, okay. And here also this can be written as 0 plus iota y, and this can be written as minus x plus 0 iota, and this can be also written as 0 minus iota y. So we see that this is lying on the positive x-axis, and obviously when the line is matching here, it is 0. And here if we come, then modulus from here to there, it is making an angle of pi radian. By seeing the appearance of the points, we can conclude this is the angle minus pi by 2, and here principal argument is pi by 2. No need to bother about tan inverse method or cos theta and sin theta method. Okay, directly we can conclude for the principal arguments on the axis. Okay, and let us now test an exemplar question on the imaginary axis. Find the principal argument of 1 minus iota by 1 plus iota. Solution: 1 minus iota by 1 plus iota equal to 1 minus iota by 1 plus iota into 1 minus iota into 1 minus iota is equal to 1 minus 2 iota plus iota square by 1 square minus iota square equal to 1 minus 2 iota minus 1 by 1 plus 1 equal to minus 2 iota by 2 equal to minus iota. See that where it is lying? Minus iota, it is on this axis. This we can write equal to 0 minus iota, lying somewhere here. Okay, so angle will be minus pi by 2. Directly you can decide, okay, by taking a conclusion on the line that since the number lies on the negative imaginary axis, therefore principal argument equal to minus pi by 2. Okay, this way we can find other argument also on the other axis.